Good afternoon, and welcome to the 2024 Frontiers of Science podcasts. The following podcasts discuss some of the most important areas of science and why they are so relevant to us today. Subscribe for more content such as this and enjoy the show in 3, 2, 1.
Welcome to the Like It or Leave It podcast. I'll be your host, and we have three amazing guests joining us today. Would you guys please introduce yourselves?
Hi, everybody. My name is Dr. Gerard, and I am currently working in Harvard University.
I am Alicia. I'm a political science researcher at Columbia University.
Hi, my name is Max. I'm a high school teacher in Connecticut and I'm teaching social science.
To start off, we're all going to define free will in our own words. Me personally, I think free will is just the ability to do whatever, whenever you want, without having to think about it twice.
I'd say it's the ability to make choices free of external factors.
And I think free will is the ability to make choices without having other people influence you on them.
All of these definitions can actually be summed up by the definition that the Stanford Encyclopedia of Philosophy gives us, which is that free will does not have a single definition. Rather, it is a term that has emerged over the past 2 millennia as the canonical designator for a significant kind of control over one's actions. For thousands of years, we've been asking ourselves the question of whether or not we have free will. However, the arrival of the internet and social media into our lives has complicated things, taking them in an interesting new direction.
You know that nagging voice in your head? The one that says, hey, maybe this isn't you. Add it to a digital audience of your peers who all seem to have a say in your life. Voila, you have a recipe for some internal conflict with a side of moral dilemma, all thanks to social media. Now, peer pressure isn't new. It's as old as that one friend who convinced cavemen to poke saber-toothed tigers, just to see what happens. The difference is, back then, it was just a handful of people. Now it's your entire social media feed. According to Pew Research, about 37% of Americans say they feel pressured to present themselves in ways that align with social norms online. In other words, almost 4 out of every 10 people are pretending their lives are way cooler than they actually are. Like they're living some never-ending music video. Then there's this phenomenon called herd behavior, which sounds cute, like sheep grazing together, but it's actually just people acting like sheep on social media. Researchers found that when people see a post with tons of likes, they're 33% more likely to agree with it, even if it's about something ridiculous, like pineapple on pizza is good, which, let's be real, is still debatable.
Relating to that, a study that I looked at on political efficacy, which is the belief in one's own vote and their idea that their vote matters in a specific election. In this study in Peru, they analyzed Facebook and Twitter specifically and showed that these two apps were the most used apps for political involvement, and saw that people created groups with others that aligned with their political beliefs. And here they chatted about different ideas like healthcare or economic policy in Peru, and it showed that when they chatted with people that shared their political ideas, that they were more likely to involve themselves in elections or different political things in their communities. And they felt that because other people were doing the same thing, that their vote mattered and related to political efficacy.
Yeah, that's very interesting. I also wanted to come back to the Pew Research survey you mentioned earlier, because I feel like young people especially are very heavily influenced by social media as well. And there's this interesting study conducted by Rob Proctor and his colleagues who were surveying students in the UK, and we're looking at how social media interacted with their online and offline personality and how young students feel a disconnect and how they present themselves online and what they actually feel like offline. So that was very interesting as well.
And all of this actually reminds me of a study my colleagues in Italy conducted a few years ago, where they explored problematic internet use, or PIU. This refers to the idea that internet use is a psychological disorder, an addiction, In other words, people are impulsive, using the internet and social media to a level where it is unhealthy. And in this study, they actually found that there are detrimental effects on physical and mental health for people who are spending too much time on their devices. They are spending more time isolated, and it is having an impact on their health in various different ways. So this is a conversation that we really need to be having, and it is very relevant for our immediate future.
To finish this conversation, we would like to hear from our listeners. Text 1-800-FREE-WILL by December 1st to answer the following question. Do you believe that social media is affecting your free will? If you answer before December 1st, then you will be eligible for a free prize.
Thank you so much for having us, Will.
Thank you. It was a pleasure to be here.
Thank you, Will. It's a pleasure.
Of course. And please don't forget to purchase tickets to my talk show, subscribe to my channel, and share this video with your friends and family. Thanks for listening.
Hey Saxies! Welcome back to our podcast. We know you missed us. XOXO!
As always, I'm the S, Sophia.
I'm the A, Alina.
And I'm the C, Christina. Today, we're here to talk about how to sack.
Sack!
No, not that type of sacking. Sack. Saving all corals.
Oh yeah, tell me about sacking.
Today we're talking about coral reefs. Why they're important, why they're struggling, and what we can do to help.
Because let's be real, climate change is making a mess of a lot of things, but coral reefs are especially feeling the heat, literally. So, why should we care about coral reefs? For starters, they're kind of a big deal.
Coral reefs make up only about 1% of the world's oceans, but they support a quarter of all marine species. That's everything from tiny clownfish to sharks that keep ecosystems balanced. Without coral reefs, the marine food web collapses.
They're also economic powerhouses. Coral reefs provide $2.7 trillion in ecosystem services every year and support over 200 million people worldwide. Fisheries, tourism, coastal protection, you name it. Coral reefs do it.
And they're lifesavers. Coral reefs act as natural barriers that protect coastal communities, including 40% of the world's population, from flooding, storms, and erosion.
Okay, here's the not-so-great news. Coral reefs are in danger. Climate change is their biggest threat, and rising sea temperatures are the main culprit.
According to a 2023 study led by J.R.S. Dorga, sea temperatures have gone up by 0.66 degrees Celsius or 33.2 degrees Fahrenheit between 2003 and 2020. In a New York Times article published earlier this year, scientists warned that if we don't take immediate action against climate change, our generation will witness the destruction of the Great Barrier Reef, the world's largest coral reef system.
When the water gets too warm, corals basically stress out and lose the algae that give them energy and color, leaving them white. This is what we call coral bleaching. In 2005, a massive bleaching event caused by warm waters wiped out half of the coral reefs in the Caribbean. Without their algae, corals can't last long, and if the environment doesn't improve quickly, they end up dying.
And it's not just a one-time occurrence. Heat waves are becoming more frequent, and the gaps between bleaching events are getting shorter, leaving coral reefs no time to recover. According to the National Oceanic and Atmospheric Administration's Coral Reef Watch, 70% of the world's coral reef areas face bleaching level heat stress from January 2023 to August, breaking the previous record of 65.7% between 2014 and 2017.
And in a 2022 research studying post-bleaching alterations in coral reefs, scientists found that some reefs are starting to shift from being coral-rich ecosystems to being overtaken by turf algae due to the stress caused by climate change, like rising ocean temperatures and frequent heat waves.
Then there's ocean acidification. The ocean absorbs carbon dioxide from the atmosphere, which lowers its pH, making the ocean more acidic. This makes it harder for corals to build their calcium carbonate skeletons and maintain their structures.
And let's not forget about local stressors. In a 2023 study of Mauritius, a small island developing state in East Africa surrounded by coral reefs, scientists found that agricultural pollution, overfishing, and unsustainable tourism have destroyed water quality and damaged coral reef even more.
So, how can we fix this? The big picture answer is tackling climate change. Reducing carbon emissions is the first step. The ocean absorbs 30% of all carbon emissions humans produce. Since the Industrial Revolution, the ocean's pH has gone down from 8.2 to 8.1, which is a 26% rise in acidity.
On a more local level, establishing marine protected areas, or MPAs, can limit activities like fishing and tourism, giving corals a chance to recover. Research, like Dorga's, have been studying specific coral reef areas to develop targeted strategies for making MPA networks more resilient to climate change.
There are also things we can do as individuals. Avoid sunscreens with harmful chemicals, cut down on plastic use, and support sustainable seafood. Little actions can add up if enough people do them. So that's the story in coral reefs, why they matter, what's threatening them, and how we can help. Saxies? Are we still here?
Oh, yes.
We're here.
Good. I just wanted to make sure you guys aren't like the coral reefs. Thank God you're still alive.
Don't worry, babe, we're still thriving, and hopefully those reefs will be too.
Indeed. Thanks for listening, and remember to stay curious, stay informed, and most importantly, stay sexy, stop all carbon!
Wait, I thought it was Saxy Save All Corals.
It's both. Thanks for tuning in, Saxies, and make sure to follow us on all platforms at Stay Saxy for Life.
Oh yeah, and our new song, Shots, 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 is out. Oh wait, I meant Sack, 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 Sack.
Welcome back to the Lorax. We're your hosts, T-Sac.
Bertha, Jordan.
Today, we'll be diving into the impacts of deforestation, the act of cutting down large areas of trees, on biodiversity, disease, and communities around the world. We'll explore how forest loss causes infectious disease outbreaks like malaria, the importance of preserving biodiversity, and the protection of indigenous lands against deforestation. Forests are more than just trees. They're ecosystems that support biodiversity, help our climate, and even protect us from diseases. So whether you're a nature and animal lover, a science enthusiast, or just someone curious about how we can secure a better future, this episode is for you. Join us as we talk about people, forests, animals, and the well-being of our planet.
So how exactly does deforestation affect biodiversity? Our forests are home to diverse species and populations of plants and animals. According to the United Nations, forests contain over 80% of all terrestrial species of insects, plants, and animals. But deforestation is causing great declines in biodiversity, and species are being forced to grapple with a number of threats. When trees are cut down and forests are cleared, it causes animal habitats and ecosystems to be disrupted and lost, often resulting in drops in the presence of species, differences in their behavioral patterns, and their ability to adapt to drastically changing conditions. One example of species impacted by deforestation was found in a scientific study looking at how climate and landscape change, both impacts of deforestation, can affect lizards in the Amazon. They found lizard species native to the area and used machine learning algorithms to generate models of current and future scenarios of habitat availability and the estimated distribution of each lizard species. It was concluded that many species of Amazon lizards will face a loss in habitat availability, with approximately 23% being clearly marked as vulnerable or potentially becoming vulnerable to population decline and extinction. The results show the need for preserving biodiversity in forest regions like the Amazon.
Not only does deforestation have massive effects on biodiversity, it also severely impacts humans and our very livelihood. Focusing specifically on human health, research has shown that deforestation significantly increases the likelihood of parasitic diseases, which are those that are transmitted mainly by bug bites. A study done in Indonesia, for instance, demonstrated that losses in primary forests led to increases in malaria outbreaks, especially in vulnerable communities. A simple 1% increase in primary forest cover reduced the probability of malaria outbreaks by 10%. These changes are possible, and their effects are preventable. This is more than protecting our ecosystem. It is also about protecting human lives. Think about it. We all lived through a pandemic that ravaged the entire planet. Why then would we put people at risk over something that only we control? Forest conservation offers immediate, localized benefits that even reduce the cost of health-related burdens by $1 to $2 per hectare annually. When thinking about how large forests are, these interventions are not only life-saving, but cost-saving. So what does this mean for deforestation and conservation efforts? It means the forest preservation is an investment not only for biodiversity, but also for human well-being.
To understand how deforestation unfolds, researchers in Brazil used Landsat satellites, which are part of NASA's Landsat program, designed for Earth observation. They collected data for 3 decades, from 1984 to 2017. By applying geospatial analysis, they classified the landscape into categories like dense forest, deforested land, and secondary vegetation. Advanced tools such as supervised classification help them identify patterns of deforestation, logging, and wildfire damage with remarkable accuracy. The results were clear. Indigenous lands like the Guajas and the Alto Turigu territories showed the lowest rates of deforestation. In contrast, other protected areas, such as the Gurupi Biological Preserve, suffered significant forest loss due to illegal logging, mining, and even large-scale fires. These insights demonstrate the value of combining traditional indigenous stewardship with modern technology to monitor and protect forests.
That's all for today. Thanks for listening, and don't forget to make the switch from Chrome to Ecosia. It's free. And plant one tree for every search. Also, sign eco-friendly petitions at change.org. See you next time!
Oh my gosh, you guys! Welcome back to Cosmic Curiosity! I'm Jennifer Coolidge, and I'm here with Einstein, Niels Bohr, and Max Planck. And today we're going to talk about something called quantum teleportation.
Today we will dive into quantum physics.
It is a field of probabilities, not certainties, and becomes most apparent within the smallest building blocks of matter.
So you're saying these tiny things don't play by the same rules as my purse or my Chihuahua Rufus?
Precisely. In the microscopic world, objects behave predictably. But at the quantum level, particles follow probabilities. This is illustrated well by the double-slit experiment.
Imagine electrons fired at a barrier with two slits. They create an interference pattern, as if they were waves overlapping. Unobserved, their location exists simply as a probabilistic region of space. This is wave-particle duality. An electron behaves both as a particle and a wave.
Wait, like the ocean? Like my house in Malibu?
It is more of a wave of probability where the particle is most likely to be. For particles as small as electrons, this wave-like behavior becomes more apparent.
I called entanglement spooky action at a distance for a reason.
Oh, spooky. Entanglement?
Quantum entanglement. When two tiny particles interact and separate, they remain connected. Measuring one instantly reveals information about the other.
Oh, so they're in a long-distance relationship but still know what the other is up to?
Yes, entanglement simply means that, at one point, two particles form part of a system that we can know certain things about. For example, subatomic particles all have something called spin. They can either have spin up or spin down. No two particles can have all the same quantum properties. So if two particles share everything else, then we can know that one spin is up when the other is down. But often, a particle is in a spin superposition, meaning its spin is both up and down.
And the topic of today's episode, quantum teleportation, where the hell does that come in?
Two particles can become entangled even when they are both in a superposition. One important thing about superpositions is that once we observe a particle, the superposition collapses, and the particle is measured as having either spin up or spin down. If this particle has been entangled with another particle and the spin must be opposite each other, then the moment someone measures the spin of one and say it is spin up, the other spin is fixed as spin down.
Quantum teleportation involves transmitting the quantum state of a particle using entanglement. In modern studies and developments, we can see how this process could revolutionize secure communication and computing as quantum systems are sensitive to observation.
Oh my gosh, so my text could be unhackable? That's just fabulous. So far, this has really been a trip. Particles doing the cha-cha, spooky long distance relationships, and teleporting info?
You're right that in theory, entangled particle would allow us to know if a third party were to access information about either one. And this is being referred to as quantum cryptography. At the moment, its range is small and the hardware required is expensive. However, it's a vital step in fending off threats from quantum computers in the future that might crack current encryption techniques.
Quantum cryptography uses entangled particles to create secure keys for encrypting messages. The properties of subatomic objects under quantum physics allow for this secure communication. A quantum property cannot be observed without disturbing it, and whole particles cannot be copied.
If someone tries to intercept the entangled photon carrying the encryption key, their actions disturb the system and alert the users.
But this is something for the new generation. Instead, I think it might be time we observe something else. I hear Legally Blonde is quite popular.
Well, thanks for the crash course, guys. Now let's go watch Legally Blonde. I hear the physics of the bend and snap is also revolutionary.
Leave a comment to enter our superposition giveaway. 2 people will each receive a single shoe, but will forever be entangled with the other lucky one.
Those were some fascinating discussions, and hopefully they will inspire you all to have similar conversations with your friends and family about the world around us. As always, be sure to leave a like and share these amazing podcasts with everyone around you. Thank you for tuning in.